Hello everyone, it's Tom here. Today I'm going to show you how you can solve a quadratic equation by using a method called completing the square. Now I know that this is not the only method you can use. A very common method is to factorize it first and to solve the equation that way. If you want to use that method, you can check out my other video. There I'll show you how you can factorize any quadratic equation easily and fast. So let's focus on completing the square method here. So what we need to do when we get an equation like this one, the first thing to do is to make sure that the coefficient of the x squared term is 1. So here we have a common factor here of 2, so we need to divide the whole equation by 2 first. So we now have x squared plus 6x plus 8 is 0. Now I know that there are formula out there that you can memorize in order for you to use the completing square method, but I don't like formula because sometimes you might forget or you might get things mixed up. Certainly under pressure situations like tests and exams, that's when things tend to go wrong there. So I'll go through the first principle with you so you understand exactly why and how to do this. Okay, so let's take a look at this expression, x plus k all square. X being a variable and k is a constant, and it's a very basic common one that you should know what that expands to. So when we expand this, we get x squared plus 2kx plus k squared. And this is how completing the square works. So we need to first of all compare the coefficient of x. So we have 6 here and 2k over there, so we need to equate them. If 2k is equal to 6, that implies k is equal to 3. And if k is equal to 3, k squared must be 9, right? So now we need to rewrite the whole expression in this format. So x squared plus 2k is 6x plus k squared, which is 9. Okay, so wait, you say we didn't have 9, we had 8, which means that we've added 1 extra. Now if we've added 1 extra on the left hand side of the equation, what you need to do then to make sure that you add 1 extra on the right hand side as well. So basically we're adding both sides with 1, then the equation still stands. Now we can factorize this into this format. So we have x plus k. What was k? K was 3 all square is equal to 1. Great. Now take the square root on both sides. So square root of 1 is plus or minus 1, because positive 1 square is 1, minus 1 or negative 1 all square is also 1, right? So now if we can solve for x, we have minus 3 plus 1 or minus 3 minus 1, which is minus 2 or minus 4, and that's our answer, which means that our original equation can be rewritten as x plus 2 times x plus 4 equal to 0. We take the opposite of the minus sign here and change it to plus and plus. Okay, it's quite simple, yeah? So let's do another example. Okay, let's try this time. X squared plus 2x minus 8 is equal to 0. Alright, so compare the coefficient of the x term here again. So we have plus 2, and that is 2k. So if 2k is 2, k must be 1. And if k is 1, then k squared must be 1 too, right? So rewriting in this format, so x squared plus 2k, which is 2x, plus k squared, which is 1. And now if you look at the original equation we have minus 8, and now we've rewritten it to plus 1, so we must have added 9 to make that happen, right? So since we've done that to the left hand side, we added 9, we must add 9 to the right hand side too. So now we rewrite the equation into this format. K is 1, yeah? So x plus 1 all square is equal to 9, which means that x plus 1 is square root of 9, which is equal to plus or minus 3, yeah? Same reason as before. So that means that x must be equal to minus 1 plus 3 or minus 1 minus 3, which is 2 or minus 4, and that's our answer. And again, that means that this equation can be rewritten to x. Take the opposite of 2, which is minus 2, and the opposite of minus 4 is plus 4, is equal to 0. That should be quite simple, quite easy to follow. If you have any questions, give me a shout and I'll try to reply as quick as I can. If you enjoyed the video, please give me a like and subscribe, and I'll see you in my next video. Thank you, bye.